So one of the things I'm asking you to do is to fill out an analysis strategy worksheet where you identify the different tests that you plan on running based on the hypotheses and the design that you have. Hopefully, this should be fairly straightforward, and most of you are going to be running a very similar sort of analysis, which we'll go through in just a little bit more detail, and is also talked about more in the complex designs section, so you can take a look at that in order to orient yourself a little bit more to a two-way ANOVA. Some of you will also have additional analyses, and I wanted to just touch on that a little bit more so you'd have some background and be able to think about whether your question encompasses that or not. So when you have two independent variables that are both between participants, the go-to way to analyze this is a two-way ANOVA. Now, of course, there are all sorts of variabilities here when it comes to whether you have a continuous independent variable or you're splitting them into groups. I think for simplicity's sake, we're going to treat this like two independent variables that are both between participants and that have separate groups, in which case you would have that two-way ANOVA. As a reminder, you have three tests that you're running: the main effective variable A on your dependent variable, and the main effective variable B on your dependent variable, and the interaction between the two. If you're looking at the main effective variable A on the dependent variable, on your worksheet, I want you to go ahead and specify which group you think will be higher on the dependent variable. And if you have more than two levels, your pattern is going to be a little bit more complicated. So I want you to be a little clearer about the pattern and to recognize you'll have to probe for differences in order to see where they are, rather than just doing a simple contrast between those two groups. Likewise with the main effective variable B on the dependent variable. You want to specify which variable is higher in your hypothesis, and if you have more than two levels, just go ahead and clarify what you think that pattern should be. This is just a reminder of the different types of interactions that your book has that you can clarify a little bit more in terms of what pattern you expect to see. Do you expect to see one combination to be especially high compared to the other three groups? Do you expect the relationship to flip or change direction depending on the level of variable that you're looking at? Do you expect one group to change and go from low to high, where the other group stays the same and doesn't experience a shift? Do you expect to see a divergence where the two groups start off the same at one level and then split at the second level? Let me go ahead and give you an example of a two-way ANOVA study. So the Powell and Smith study that you have access to on Canvas in your supplemental materials is an example of a 2x2 design where in study 2 of that particular paper, there were participants who were exposed to a person who either made a moralizing statement about cheating or didn't moralize about cheating at all. And then participants read a follow-up where that person that they had just read about either got caught stealing or got caught cheating. And then I measured things like impressions of hypocrisy and schadenfreude. Now, if you can imagine the dependent variable along the y-axis, one of the things that I found is that when participants read about the person who was moralizing, so we're going to think of that as the solid line, and they read about that person being caught cheating, which we're going to think of as the A2 section on the y-axis, that people experienced a dramatic increase in their reported levels of hypocrisy and schadenfreude. So the graph looked very similar for both of those dependent variables. I had essentially a spike where the moralizing cheating group rated the highest compared to the other three combinations. And so if you are anticipating that you're going to have a spike where a specific combination is going to lead to much higher results compared to the other three groups or combinations, then that would be the sort of thing that you would expect you would see. Hopefully that makes visual sense to you. And once again, you can compare this graph to the actual graph in the article and see how it aligns. It might be oriented slightly differently, but the same basic notion still applies, this notion of a spike where one group is different from the other three. As a reminder, if you have a pretest post-test design, your pretest post-test is a within participant variable because the same group of people take the test twice. That will make it a mixed design, and you would have to run a mixed ANOVA instead of a two-way ANOVA. If you have a pretest post-test design, come see me because your analysis strategy will be a little bit more complicated. I will say, for the most part, I've been steering folks away from a pretest post-test design and encouraging them to only administer post-tests. If you're already randomly assigning, then it's fine to just give a post-test, and it makes your analysis strategy much more straightforward. Another potential analysis that you can run that I really do want you to think about, especially when you have more than one dependent variable that could be interrelated to one another, is a mediational relationship. A mediator is a variable that explains why the independent variable leads to differences in the dependent variable. We've already talked a little bit about mediation in class, but I wanted you to think about it as it relates to your particular study. You would test this using what's known as a bootstrap mediational test, and we're going to be learning about how to do that next semester, but I did want to introduce you to the basic structure of a mediational test so you could see if you have the potential to want to test for mediation in your study. So as an example of classic mediation, temperature consistently positively relates to homicide rate. The mediating variable is irritability. So temperature leads to an increase in irritability, which then leads to an increase in homicide rate. We're able to explain the relationship between temperature and homicide rate due to irritability. So we would identify irritability as a potential mediator. Here's another classic example of a mediational relationship, where research has found that as the number of people increase, helping behavior decreases. This is due in part to diffusion of responsibility. As number of people go up, diffusion of responsibility goes down, which in turn reduces helping. Because of diffusion of responsibility, the number of people reduces helping. If diffusion of responsibility didn't exist, then that relationship wouldn't exist either. Here's one final example of something that you might see in an experiment similar to what you're doing. I manipulated the status of a rival in a study where I had participants read about a high or low status rival, and then I took a look at how that related to rival-related jealousy. So that was how jealous people reported being toward the rival. I suspected that envy toward the rival was one of the things that was driving this particular relationship, and that high status would lead to more envy, which in turn would lead to more jealousy. So you can see how it's a path relationship where I use envy to help explain the relationship between status and jealousy. Some things to consider are whether you have a balanced model. So a balanced model is whether you're expecting an increase or a decrease in any of your paths. And these are the three balanced models. This is kind of like the enemy of my enemy is my friend sort of thing. So for example, if you have a positive relationship between your independent variable and your mediator, and a positive relationship between your mediator and your dependent variable, you must have a positive relationship between your independent variable and your dependent variable. Likewise, if you have a positive relationship between your independent variable and mediator, but a negative relationship between your mediator and dependent variable, then it means that you have a negative relationship between your independent variable and your dependent variable. And then you can see how we have a negative relationship between the independent variable and mediator, a positive relationship between the mediator and dependent variable, and a negative relationship between the independent variable and the dependent variable. So to classify this a little bit better, let's go ahead and go through an example. In one of the examples I gave, I expected there to be a positive relationship between status and envy, and then I expected there to be a positive relationship between envy and jealousy. And I also expected there to be a positive relationship between status and jealousy. Can you see how that fulfills the top model? When we're talking about helping behavior, the more people that are present at the scene, the more diffusion of responsibility there is. The more diffusion of responsibility there is, the less helping there is. And the more people there are, the less helping there is. Can you see how that fulfills the second version of this model? Hopefully that makes sense to you in terms of what a balanced model needs to consist of. I'm asking you to clarify the expected direction of your analysis in your hypotheses if you go ahead and work through it. And if you have any problems with this, I'll be sure to let you know. When it comes to identifying mediators, there are different things to keep in mind. The first is what comes first, and what comes second, and what comes third. So what is the progression that you think should exist? Sometimes these things are fairly obvious. So for example, if you expect that someone might have a certain level of, say, perfectionism that they come into the study with, then that could be something that is a potential mediator rather than an outcome like performance or stress that you think might be impacted by your study's variables. So something like personality or once again a general tendency or attitude or habit, that would be a good potential mediator rather than a dependent variable. And then you think about whether it's a manipulation, whether it's a reaction to the manipulation, or whether it's the ultimate outcome. So for example, jealousy was the ultimate outcome in my study, the thing I was most interested in. I thought of envy as a reaction to status, which was my initial manipulation, and jealousy as the ultimate outcome that was impacted by all of these things working together. So you can see how that put it in order in terms of manipulation of status, reaction to the manipulation of envy, and ultimate outcome of jealousy. So you can think of a mediator as a bit of a hybrid between a predictor and an outcome. It's not quite an independent variable, it's not quite a dependent variable, although usually it will be one of the dependent variables that you're measuring. But it kind of could function as a switch hitter. Sometimes it could function as a predictor, sometimes it could function as an outcome. So it's basically an outcome of the main independent variable, but a predictor of the main dependent variable. So it kind of functions in between. Think of it as the why, or a bridge, to help explain the relationship between your independent and dependent variable. If you're measuring a lot of different things, you might take a look at one of those and go, is that helping to explain my relationship between my independent variable and the dependent variable I'm interested in for my ultimate outcome? If so, that could fulfill a great role as a potential mediator. So let's go ahead and take a look at an example that I've used before. So smoking, stress, and heart disease. There's also substance use, behavioral impulsivity, and violent crime, or gender, math performance, and self-stereotyping. You can see how you can sort these into different categories in terms of pre-existing states and behaviors or outcomes. So for example, you might ultimately be interested in taking a look at how smoking and stress impacts heart disease as your ultimate outcome. You might be interested in how substance use and behavioral impulsivity impact violent crime as your ultimate outcome. And you might be interested in how gender and self-stereotyping impact math performance as your ultimate outcome. So in the first example, heart disease would be my dependent variable. In my second example, violent crime would be my dependent variable. And in my third example, math performance would be my dependent variable. Now, there are certain things that I would think of as being pre-existing, or the initial impetus for whatever the mediator is. So in the first example, for instance, I would think that stress would lead to more smoking, which in turn would lead to more heart disease, so that smoking could be a potential mediator between stress and heart disease. Likewise, you can make the argument that behavioral impulsivity leads to more substance use, which in turn leads to more violent crime. So that behavioral impulsivity is my independent variable, substance use is my mediator, and violent crime is my dependent variable. Gender is a pre-existing condition. That kind of has to come first. But you can expect that gender leads to more self-stereotyping, which in turn impacts math performance among women differently than men. So you can kind of see how these different things set themselves up once you think a little bit more about what has to come first by necessity, what your ultimate outcome is, and what the bridge or gap is. In the first example, I think smoking is the why that might help explain a link between stress and heart disease. In the second example, substance use is the why that might explain the link between behavioral impulsivity and violent crime. And in the third example, self-stereotyping is the why that might explain the relationship between gender and math performance. Hopefully you're starting to see a little bit of a pattern here in terms of how you might identify potential mediators in your own study. And once again, being able to classify something that's a more final or ultimate predictor, the thing that you're the most interested in taking a look at, can help you identify what is supposed to be your dependent variable, and then the other things might serve as good mediators. So it's important to be able to distinguish between interactions and mediation because it's very easy to get the two of them confused. When you think of a moderation or interaction, you think of a split, a flip, or a warping of the relationship between the independent and dependent variable. That something changes depending on the level that you're looking at of your other independent variable. So For example, at one level there's a positive relationship, at another level there's a negative relationship. Something flips, something splits, something warps. It's like the branches of a tree. Whereas mediation is more cohesive. Rather than it branching and splitting and dividing and diverging, it's bridging, it's connecting, it's linking these things together. It's a bridge as opposed to branches of a tree. So it's more that the mediator drinks the milkshake of the relationship between the independent and dependent variable. It explains the relationship between those two. It connects them. It's linked to them. It's a bridge. In terms of another analysis that you might consider, you might be interested to explore whether your dependent variables are related to one another in any way. That would be explored using a correlational analysis. So when you have multiple dependent variables, which I recommend that you have just to make your study a little bit more interesting and complex, you can actually measure how they correlate with one another and develop a hypothesis about whether you expect there to be a positive relationship where both variables increase together, or a negative or inverse relationship, whereas one variable goes up, the other goes down. So for example, going back to my very first study that I went through for interactions with hypocrisy and schadenfreude, I said that both of those graphs looked very similar to one another. And indeed, hypocrisy was correlated positively with schadenfreude, so that if people rated something as being higher in hypocrisy, they also felt more pleasure at that person's misfortune. So I was able to demonstrate that with a bivariate correlation.